Okay, TCP/IP class. I've been really behind on this one. Sorry about that. I'll try to get caught up. I've been trying to get caught up in all the others, and I've done that except for in this one. So today we're going to look. I'm going to start on page 158. You were supposed to do reading of that. We're going to go through and we're actually going to track through the Ethernet frame, and then I'll post another whole video about ARP. These actually are ARP packets just because ARP packets tend to be smaller. Remember that the smallest Ethernet packet or frame, sorry, since we're layer 2, the smallest Ethernet frame we're going to have is going to be 64 bytes. I did make an error because last time I believe I said the frame check sequence is at the end, and I forgot. In this instance of Wireshark, it actually doesn't show you the preamble or the frame start delimiter, and it does not show you the frame check sequence at the end. So we had the smallest frame that I could have. Can I make this bigger? Smallest frame that I could have would be 64, which would be, these are 16 bytes here, so I would have 4 full. I'm missing the frame check sequence, which is 4 octets. It's 32 bytes long, so those 32 bytes actually go right there in that spot. So we will not see, and it's good. We don't have to worry with the frame check sequence in that. All right, so let's look at, since there's not much going on this, and really we only need the very beginning, we need to look at, and actually we can open this up, and it tells us up here, we're going to concentrate down here. Eventually you're going to be able to look up here. I mean, I guess beginners would look up here, and there's the frame, and then there's the Ethernet portions of the frame. So we've got the destination MAC comes first. Remember that the MAC address is 48 bits. It's 6 hex pairs. 6 times 8 is 48. So these are the 6 hex pairs of the MAC. That's the destination MAC. Now, one of the things, this goes destination, then source at layer 2, and then like the ARP will be backwards. You'll actually see that it's inverted here when we finally get up to that, but the other layers are reversed. So this is destination first, and then the source MAC. So there's the source MAC 00027168DD76, and then that is the type. So if you would look on page 158 in the textbook, if you look on that, we had the preamble. Remember, the preamble was a series of 1s and 0s with 1 1 at the end, and I do have a video for that. Let me grab the book real quick, and I'm going to grab that video. I'll be right back with you. Okay, I'm back. This is the diagram from page 158. And so we have the preamble here, which gets lopped off. You don't see that. And then start a frame delimiter also gets lopped. Destination address comes first. 1, 2, 3, 4, 5. Whoops. Starts here. Sorry. 1, 2, 3, 4, 5, 6. Then we get a source address that is also 6. 6 times 8 is 48. And then the type. Got a bunch of data, and then the frame check sequence, which is the last 4, which is going to get lopped off. All right, I've got, this actually is a really, really good video. I'm going to put on my headphones so I can listen to. It is a little bit long.
The data transmitted between computers into smaller pieces of data called
it started
frames.
blah 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 blah. Talks about transmission back and forth.
The entire web page, etc.
Basically, it talks about we need frames because instead of sending an entire message across, having something fail, if anything drops out, we would lose everything. We can send it frame by frame, and then you just have to resend individual frames. So this is the part that I'm interested in.
5 pieces of information. the MAC address of the frame's recipient, the MAC address of the sending system, the type of data encapsulated inside that frame, then you have the actual data itself, then you have the frame check sequence. So let's just go over those shortly. An Ethernet frame always begins with a preamble. Now this is a 64-bit series of ones and zeros that always end with 11. When this is sent at the beginning of a frame over a network, the NIC of the receiving device reads the preamble and realizes that a frame is coming immediately after. This preamble, ending in 11, also tells that receiving NIC exactly where the frame starts. The frame, including the data that's in that frame, has to be a minimum of 46 bytes, with 18 bytes of the frame header and trailer. The preamble isn't considered part of the actual frame. It's just to kind of give a heads up. The second and third fields of the frame actually map out the destination and the sending NICs with their respective MAC addresses. You have the destination MAC address first, then you have the sending MAC address respectively in that order. When you get into switching and layer 2 devices, this is where those switches and layer 2 devices learn the MAC address of the sending device from that frame, from the sending MAC address. And thereby, they learn what's connected on that interface. And so more on that in other videos, but just wanted to kind of give you a heads up on that. The next field is the type field of the Ethernet frame. Now this field gives the receiving computer a very basic idea of what the frame contains, whether it's IP version 4 or IP version 6, etc. Now this confuses some when they're studying for or learning about networking, as this field, this type field, does not tell you if the frame carries what is referred to as higher level data, like a Word document or an email or a web page, etc. It doesn't really tell it that. Once you get into the data section of the frame, that determination can be made as to what type of document or what type of data you're dealing with, higher level data. Rather, this type field is only a basic kind of a heads up on what the frame contains for the receiving computer NIC. Then you actually get to the data field of the frame. This is the field that actually contains the payload, the information being sent across the network. It can be an IP packet, an ARP, or address resolution protocol, etc. Now, regardless of what type of data this field contains, the payload must have at least 46 bytes. If it's somehow smaller than 46 bytes, the NIC from the sending device will automatically add extra zeros, called padding, to the end to make sure this payload is at least 46 bytes. Lastly, in the entire frame, you have the frame check sequence field, or the FCS. This field helps the nodes on a network to know when originally good data has had something happen to it along the way. It got corrupted, it got interrupted, it got broken up, whatever the case may be. Ethernet uses an algorithm called cyclic redundancy check, or CRC, to determine if the data in the frame is good or no. This is important because devices on a network have to be able to know when data is damaged or corrupted during transit. To detect errors, computers using an Ethernet network attach this FCS field code to a frame by doing the following. The sending machine, when it's first creating the Ethernet frame, runs the data through a mathematical formula called the CRC algorithm, and it attaches that result to the end of the frame in this last FCS field. Now this is referred to as the trailer when we're dealing with frames. When the receiving machine gets the frame, it performs the same exact calculation using the same algorithm, and it compares its answer to the answer that's on the trailer, or that's added to the trailer field, the FCS field. If they match, the receiving or destination machine knows that that frame is good. It hasn't been corrupted or damaged along the way, and it goes ahead and opens that frame to fully receive it. If, however, the answers don't match, the machine receiving just kind of drops that frame. That's what we call it in networking. It just drops that frame and allows the higher level layers or protocols like TCP to handle the retransmission of that frame if it's needed. And that's essentially how an Ethernet frame is built, used, and understood on a computer network. If you'd like to get in on
Okay. I think that was good, especially walking down through. I think that was a good thing. Now, the preamble and the start of frame delimiter. So it's binary. It'll be 10101010. alternating ones and zeros in binary. There are 7 of those, and then there's one that ends in a 1-1. So it's if the decimal equivalent would be 170, 170, 170, 170, and then the very last one is 171. So what that allows is the other network card to be tracking the incoming, and it allows it to synchronize. So it can see the inbound packets, and it knows the frequency rate that they're coming in, and then it sees the start of frame delimiter, which is the 1-1, and it knows the next thing is what it really needs to pay attention to. Now, he mentioned the packet has to be 40, the data element has to be 46. Now, don't get this confused. This does have to be 46. Why does it have to be 46? Well, all the other pieces have to be included in it as well. So we got 12 here. I got 14. And then I got 18. 18 plus 46 is 64. So this, in total, the entire frame has to be 64 bytes. Since we already have the 12 up front, plus 2 here, and 4 at the end, we already have 18 bytes that are doing other things. We have 46 bytes left, and as he said, it will pad the rest of that. So it has this data field. So this is the exact same thing we were just looking at. It's just in a slightly different layout. The data field will be just as long every time, or at minimum. It could be longer, but it will be at least this long. And if it doesn't have data, it will pad it with zeros. So all these zeros stuck at the end here are because the frame wasn't long enough. All right, so this, I just minimized it. This layout is going to be one that we're going to start going over. Actually, I'll post the, it actually has several different packet layouts, but we're going to not pay attention to the preamble, because when we do packet captures, we're not going to see that. So it'll be destination of 6, source of 6, type of 2, then data, and then again, we won't have the frame check sequence. So Wireshark is not going to capture that, and it's not going to capture the preamble. You will be able to look at, you will need to be able to look at that and be able to tell the things that, the only thing that we really care about right now is type, and right now we'll have 0800 will be an IP related pack, IP version 4, and 0806 will be an ARP packet. So ARP is going to be the next thing that we're going to do. And if we go back to, let me move that out of the way, we can see here there is our type 0806, which shows that this is an ARP packet, and we know it's an ARP packet because of that. If I get rid of my filter here, let's grab a TCP packet, and you can see the same field there is 0800. So I still have the destination MAC, and then I have the source MAC, and then the very next thing after that is going to be the type. So I know it's IP. Now, I don't know whether it's from this, I don't know whether it's a TCP packet or a UDP packet. It could be DHCP, it could be DNS, it could be all kinds of things. I don't know what it is. I know it's not an ARP packet, because ARP would be 0806. I know it's some type of IP version 4 packet. Beyond that, I can't tell. And then the data starts here. We're actually going to crawl back through. That was what chapter 3 was. So I'm going to go through ARP, which is in chapter 4, because it's simpler, and then we're going to go back and we're going to start working through our IP packet types. So you guys have all done packet captures. You should be able to look back through those, or just fire that up again. If you type, and it has to be lowercase, if you just type ARP and hit enter, it will find an ARP packet, and then you can track back down through. This is nice because you can click on those and it will tell you what they are. You need to get to, pretty quickly, you need to get to where you can find that out just by looking. And it is pretty cool when you finally get down to, I'm going to give you a packet. Actually, we're coming up pretty quickly on that because I'm so far behind in this class. Again, I apologize. But we are, you're going to get a homework assignment where I'm going to give you a series of packets, and you're going to have to start breaking them down. So you're basically going to, you circle the first 6, that's destination, circle the next 6, that's source, circle the next 2, and that's going to be the type. And actually for this, for Ethernet, for layer 2, you're done. When we get to ARP, then you'll keep going on that, and you'll figure out what the parts are from there. So we're coming up on some hands-on where you're going to be able to download, and we'll probably color code everything. I don't know. We did this in person last time, so I had printouts, and you had to write down and mark things out. So last time was the first time I taught the class, and now we're doing it in a totally different format. So I'm just kind of playing it by ear as we go along. But you should have read, or should be reading, page 158, actually starting on page 158 and then reading through. We're going to get through ARP in the next section, so if you want to get a jump start on that. Otherwise, the next video will be about ARP. All right, talk to you next time.